So our environment is set up now. Now we'll use ChatGPT right now to understand Rust as well as Python. But we'll go with Rust first. So this is our day 4, and we have a concept given by ChatGPT. It is enums as type level modeling. So we don't know what is enum and we don't know what type level modeling is. So we start clean. Now, why enum exists? So from first principle, it means from basics, we'll know why enum exists. So when designing system, you often have a fixed set of possible states and a fixed set of operations, a fixed set of messages types. Like example of calculator operations. So name design is something like calculator, and you'll pass some operator, then a number A, then a number B, and you'll calculate it. You know? But the problem is any string is allowed, and typos can compile, and runtime errors instead of compile error. We get runtime error. Like when we run that calculator app, and we can do something stupid with it, and we'll get a runtime error. And no exhaustiveness checking is there, and no modeling guarantee is there. So this is called strictly type design, but we want a type level modeling, I guess. So strictly type designing is something that scales very poorly, and it is just workable with like minimum thing that can work. Uh, yeah, this is a strictly type design. Now enum is a closed set of variants. So enum has operations, and we can define add, subtract, multiplication, and division. Now this means only these four possibilities exist. No other are possible. Now compiler knows the complete set, and this is called a closed algebraic data type. Now closed means that cannot be extended at runtime. So compile time guarantee is that if you write calculate and then operation OP is passed and you match operation OP, and if it says add, you add A plus B. If it says sub, you subtract. If it says mul, you multiply, and if it says div, you divide it. And A and B are the passed number in this function called calculate. And this will return a type F64, which is again a float 64. Yeah, when you operate on two numbers, you get a number. That's maths. And now you cannot pass invalid operations. If you add a new variant later, like something else, something like 2 stars as an operator, as an operations, so the compiler will sort of show that it is invalid because it will not pass it. Yeah, so you cannot pass invalid operations even if you try to. And if you add a new variant later, compiler forces update. So this is exhaustiveness checking. And what actually gets stored? So simple enum without data. Simple enums without data, like internally stored as a small integer, discriminant like 0, 1, 2, 3. And there is no heap allocation, extremely cheap comparison. And so enum comparison is integer comparison. Now concept check is answer precisely. Why is enum based design safer than ampersand str for modeling operations? First, PCA, because we define few operations and no other operation are allowed or passed. That's not defined. So it is sort of defined. So he makes state model or is true. Why? What does closed set mean in context of enums? Closed set means that whatever is in the closed set only exists. Other than that, nothing exists. So it is safer. Now, if I add mod to the enum, what happens to existing match statement? Since mod number 3. So since mod is not an operation defined in the enum, so this operation doesn't happen. So it becomes invalid and doesn't pose runtime error. Now there's 4 questions. Will this compile? Add and subtract, are there only add and subtract? So yes, this will happen. But wait a second. What does add do? Let me check this example. So here we are defining that add does a plus b. But since there is no a and it is just returning a constant number, there is nothing wrong with this. It just subtract is not defined and not used. It has an issue that the subtract is not defined, so can cause runtime error. Implementation task is so will not compile. Now implementation task is create a minimal program with an enum defined as operations, and then in the function main we get a operation that is op operation add, and then we match op. So here it is add, so we'll add, which is println addition. Type it manually, do not copy and paste it, run it and confirm it compiles. So let's do it. All right, add, multiply, divide. So we'll just make these. That's all right. It seems easy, but let's see. We'll create a file called what? 4. Yeah, 4.is, and inside that we'll create first of all enum. Sorry, first get into insert mode. Now we'll create enum. What is that? How enum is defined? Enum and then name of that enum. Operation of operation operation. Inside the operation, we'll use curly brackets to define add sub sub tract subtract multiply, and then divide. Or we are just adding add sub mul and div. What is that? Yeah, yeah. It's not full, so it's like this. Sorry, it's div, it's month, it's subtract. Yeah, it's like this. Should we add a comma after divide? Yeah, we should add a comma after divide. Now we'll define a function called main. All right. Now in that we'll say let operation as op be operati operation add, and when that happens, operation add, what is up? Oh, sorry, just done. And when that happens, we match op with operations like is it correct? Let's see. Yeah, with operations like operati operation colon add. So in this case, this will happen because right now OP is add, and we have made a mistake. Like we have let LED let, damn it. This is OP and then it's let. Is it all right? Hash. Now this will print instead of just adding it. It will print addition. I guess this is what we'll do. Yeah, addition, subtraction, and multiplication. There's no this because it returns values. No need to add semicolon. Operation sub is defined as, we'll just print ln. What we'll print is subtraction and a comma, and then operation is there called mul, and capital N ul. It is defined as print ln multiplication, and then there is div operation, sorry, operation div. There is a spelling mistake. Operation operation div, which is defined as, we'll just print division, print ln divi division, and add a comma. That's it. Print ln is wrong because it needs exclamation mark. It's macro, so it needs exclamation mark. I guess we have completed our program. Simple program, isn't it? Yeah. So we've typed it manually. Now we'll run it manually. This is 4, so we'll see rust c 4.rs. Now we got few errors. Operation. So I think there might be some spelling mistakes. Operation, operation, op, yeah. P. The defined enum is like spelled wrong. operation. Yeah, operation. Yes, now this is correct. So again, try to do this. We are getting warning that variant sub, multiplication, and div are never constructed. Why? Because it was never used, so sort of unused. We see, a note is that is dead code or part of unused on by default. So one warning is there that is emitted. And if we sort of started using sub and mul and div, we would get these also defined and used. So since we have compiled it, we'll run it by calling it 4. It runs, it is addition. Now there was an earlier question over here. We'll just take it practically, that we have defined addition but left subtraction. We did not even define it. So will it cause error? It should cause error. We say that we did not define, let's say, division, and we did not call it. So let's do this and try compiling it. What I expect is we should get a red error message. Yeah, so we got an error that enum operation div is not covered and not even defined. So it says that define it to do, you know. So yeah, we go there, undo it, not LW. Now we run it. Yeah, we just get a warning. Warning is sort of that keep it in mind. There can be something wrong. But error is it is wrong. Don't compile it. We don't compile it. Whereas warning, always compile the thing. Yeah, we have it. We are getting addition. Great. So what it's telling me is paste. So we'll paste it and we are good to go. Good. Now we refine your understanding precisely. You are mostly correct, but some reasoning needs tightening. Like why enum is safer than %str. You said define few operation and no other operations are allowed. Exhaustive model. Correct direction. But precise answer should include invalid state becomes unpresentable. So if there is invalid states, then it will become unrepresentable. Unrepresentable. What does that mean now? If there is invalid state, just give me example here. Now compiler enforces allowed values. Compiler enforces allowed values. Exhaustive pattern matching, and then no runtime string validation is required. So enum moves validation to compile time, not runtime. All right. So if there is some program that shows a sort of runtime error, we want to use enum over there so that we can see compile time error, so that we can fix it instead of getting a runtime error. So no runtime string validation is required, and exhaustive pattern matching is there, means every pattern is matched until no pattern remains untouched. And then compiler enforces allowed values only, and invalid state becomes unrepresentable. I don't know what that first statement even means, but all right. Now, second question was closed set meaning. So whatever is in the closed set only exists. Correct? More precisely would be a closed set means all possible variants are known at compile time. No new variants can appear dynamically, and pattern matching must account for all of them. And now question 3, if mod is added. So you answered incorrectly that you said since mod is not defined, it becomes invalid. Now this is wrong. What was the question 3? What was the question 3? If I add mod to the enum, what happens? Oh, we added mod to the enum. All right. What happens to the existing match statement? Well, existing match statement, where is the existing match statement? Let's say here, this is the existing match statement. And if we, no, this is not the existing match statement. Let's take this is the existing match statement, and we only add mod at the enum, so it will throw a compile error, so it will not compile. So if mod is added, you answered incorrectly. You said since mod is not defined, it becomes invalid. Yeah. If we add mod in the enum operation, now every existing match must handle mod, but we didn't define that. So if not, the compiler gives non-exhaustive pattern and it forces you to update the logic. Yeah. This is a major safety property. Will this compile? No. Sub is not defined, so runtime error. Incorrect reason. Not runtime error, it's compile time error. We'll get compile time error. So there is no runtime error involved in case of enums. We get a compile time error. It will not compile because match is non-exhaustive, like it has not been exhausted. Like there are some possibilities where match can be used, like operation sub is not covered. So Rust prevents incomplete pattern matches at compile time. So no runtime pattern. It's just compile time. You will see errors like we did over here. You know, ah, it went up. So no worries. Now about your warning. So this warning, like well, they've just added dead code warning because you never constructed those variant. It is not an error. Your implementation is correct. We sent these warning to like these warnings, and we know this is dead code. This was not unused. This was unused. So yeah, by default, this will send us a warning. Now we escalate. We escalate. Now we move to enums with data. This is where the real modeling begins. Like concept is that enums can carry data, like add can have a you know value of f64 and f64. Same with sub. Now each variant holds value. Now this is powerful. This is how ASTs or protocol messages and ML pipeline states are modeled. Implementation task is that write is sort of this and calculate over here. We have to match over here and we have to run it in main sort of. All right. So we have to do this. We have to, this is our implementation task. So requirement is division by 0 must return an error and no unwrap, no match, no unwrap, use match, use pattern destructing inside match. Example pattern is like operation add, then add AB, then we'll define it with arrows and we'll say A plus B, without semicolon. Now answer before coding. So before coding, we must answer this. So where are the F64 stored? So I guess in the enum, F64 is stored over here. In the stack or the heap. This is a tricky question now. F64 gets stored in stack, I guess. No. Since F64 is getting values while runtime, we can only store it in heap, I guess. Since we are getting value at runtime, we must be storing it in heap. Before that, I want it to ask, MCQ type questions because those are easy to answer. We don't have to type much and we don't waste time. The benefit of MCQ type question is always we get some sort of hint right in the question. So that's why. Now, since we are getting value at runtime, we must be storing storing, storing it in heap. All right, we move on to the next one, which is if I match operation add and our value A and B moved or borrowed. If I match operation add, I guess they should be copied, but let's say they are moved. But moving has different set because strings and all those things, vectors can be moved, but and borrowed. As for numbers should get copied. If not, then I guess we borrowed because enum must have them almost. I guess I'm guessing it. Not at all. Why result F64 and a string better than returning F64 directly? Why is it better? Because when we want to send an error instead of just F64, we can send it in string. So yeah, using result to return is helpful because we can send errors that are in string as well as values if we compute them. All right. Implement full function and a small main test are all four operations, including divide by zero. All right. So now implementation task is there, and we must implement it. So we'll create a fifth file. Now what we'll do is create an enum first. First you get to insert though, then enum, and enum is operation, I guess. Operation. OPTRATIO. Curly brackets. Add sub month diff. Now we say add sub month and diff. Not if it's diff. Damn it. Damn it. That's why double E. Also, why is it even there? Make it come down. Yeah. Now it's there. Oh, I did something wrong. We are also passing the values. So like F64, which is port 64, and again F64. And we are doing this for everyone. We must yank how many words? I am guessing one, two, three, four, five, six. Let's yank five. Yank five words. And now paste it. Ah, we'll do something in there. Paste it. 1x x. We have our enum prepared. Now we'll define a main function over here, and we'll assert some claims of our own. Or can we just print it? Like printing it is easy, whereas asserting can also be easy. But how about just printing it? We'll just assert it. Assert EQ, and we'll assert that add, which we send two values like 3 and 5, will give us a result of 5, I guess. Is it correct? That's how we assert now. Or we add inside the quotes. We do it inside the quotes. I forgot. Now let's do something like in calculation. We sent OP, that is a type of operation. we send a result out of it. RESULT, which has two types, that is F64 and string RING. STRING string. That's it. Hope so. I'm correct. I am correct right now. Okay. OP operation calculate. OP is type operation. OP column. That's what was forgetting. OP is of type operation. That's what we want to say. Now we open up those curly brackets. Now we use match. Match what? Match OP. We'll match OP for cases like add, and we say A, comma B, and when we add it, we send an OK. We're sending OK. Connect the string alongside OK, alongside the result. It's OK. And we'll say A plus B. Now we'll add comma. If it says not add, but if it says sub, then we subtract A minus B. A comma B. We subtract A minus B. That's for the clarity. If we get a multiply, yeah, it's one. I like to write, multi. Uh, Seems nice to speak multi, not just mul. Okay, and we do A multiply star B. That's it. In the case of div, now here is the catch. If B is equals to 0, we cannot divide A by B. You know, so we'll say that's what we did yesterday also, if we remember it correctly. B is equals to float 0. Then we say something like error uh, string from C not divide by 0. Yeah. Oh, and if there is an else, and let's see, else, what is says okay, then we send, okay, A divided by B. That's it. Should we use comma over here? I guess so. Yes. Do we use comma? We don't. Or do we? It's a confusion. Let's try running Rust. I.rs. Yeah, we get errors. Why? Because div not found in this scope. Which scope? Use operation. We didn't use them. Let me see. Yeah. Sorry. It should not be like this. It should be like operation. Sorry. Copy operation. Then these 1, 2. This makes perfect sense. Now we sort of yank 3 words. No. Yank 2 words. Yeah. Now you go there, paste it. Hold on. We go over here and we try pasting it. Yeah, works. We try pasting it. Not here. We try pasting it. We try pasting it. Now it should work. Let's see. What is it? Expected one of the kind. Yeah, it did not expect. So comma over here at the end. So we can remove it. No worries. What else? What else? Tell me, tell me. Now string from cannot divide by zero. So from is capital F. We've used capital S. F, it should be small f. Uh, what else? What else? Tell me. Tell me right now. What is wrong? Expected one of these and not expected a comma. All right. We'll remove the comma. We'll remove the comma. Tell me what else? What else is there? Oh, sorry. Add, not found in the scope. It's not add, it's operation add. Yeah, we remember. Where are we? Come on, say print. Oh, damn it. OTER array operation. Operation add. Is it correct? Should be. Now what? The trait debug is not implemented for operation. In an operation must implement partial equality integer. Derive debug. Oh, why? Did we do something wrong there? In an operation. So let's do derive debug, but I think there is some problem with, assert equals. I guess it should be sort of statement wise here. And I guess result is sort of too stringify or something like that. I have to use it. There is some problem with no implementation of ampersand str is equals to this. So what I'll do is, instead of writing this assert claim that is wrong, I'll try to just print it. Print ln. What we'll print is a value, and that is coming from operation add. Whatever is coming from this, we'll just print it out. That's it. Now what? The error has reduced, but there is still an error required by this formatting parameter. Operation cannot be formatted with default formatter. I think I have to extract values from operation, but I forgot or I don't know how to extract that. So it's telling me to just use a debug mode where we add colon and a question mark, but to do that we have to say we have to say derive debug. Yeah, debug. That's it. Now it has compiled and it can work, but it's still suggesting me something to improve my program. Yeah, we are getting a value of, instead of getting a value, we're seeing this, which is not correct in our case. We must see 8. Instead we see this, which is not what we intended. So what we'll do is Yeah, it's wrong. It's wrong. It's wrong. Why it's wrong? Why is it wrong? We have to send something in calculation. So we'll get into calculation. Inside that, we'll send an OP, that is a type operation. Let's say we'll send add, isn't it? And which is of type operation. And inside that operation, we have to send two F64s. One, two. Only brackets are there. This is for this. You have to add more. This is for this. This is for println. This is for calculation. This is for add operation. These are for numbers. All right. I guess we'll get a something called a result. Let's see what we get. We get error, not result. Sorry. So it's telling us don't use brackets over here because F32 did not use bracket. So we'll remove them. No big deal. Earlier it was just suggesting us. Additions can be wrong sometimes. Now there's an error. It says use operation. All right. Operation add instead of just add. So we'll do that. So we operation and add what we get over here. Yeah, I guess it compiled. And it's only sending us warning that subtraction and multiplication and division has not been used in a program. That's none of our worries. Now we get an OK and 8.0. All right. So we get a string and we get a result. That's what we expected. It was not complex. It's just we was sort of stupid, or we are just beginners. What I can say is this is not what I expected, but it's good. It's good. Can we write a new assert? No, assert operation. Let's try writing it. Assert. Inside that, we'll say, send something to the function called calculation. Send it with OP, that is operation. And instead of sending add, we'll send subtract. And instead of sending 3 and 5, we'll send 5 and 3. No need to use a brain. Just use it in coding. And I guess this is complete. And we should get OK and 2 point. And that should be our result. If we don't get that result, we'll get an error. This is good. Now, since we use subtract and didn't use multiply and divide, it's telling us we did not use it. We have a compiled. We see the output. We don't see the output for assert. That is good for us because now it means that assert made its claim and got the response it had wanted. But there is no dramatic effect for asserts, like we don't see things happening in assert. Now, what was wrong over here was, first of all, what if we don't say okay? What if we say it will just send you to point? If it says no, we should also be getting okay. All right, so stop us. Let's say okay. Without that, you will not get what you want. All right, please say it. Okay, so now just save it and yank everything out, and we'll paste it over here. Good. You implemented correctly. Now we tighten the conceptual accuracy using MCQ as requested. Now, where are F64 stored inside operation add F64? Uh, I guess that it was on heap. Now it says inside the enum value itself. I guess C will be answer. All right, we'll read it. So it gives us an option like always on heap, always on stack, inside enum value itself. So now I'm guessing this and stack if enum is stack allocated, which it is. Enum is stack allocated. So I'll guess C as an option. And always on stack, no. Always on heap, no. Inside a box, automatically, not automatically. You have to define everything. Now, before correcting you, you answered since runtime value, then I answered it's heap. Now that is incorrect because Rust does not allocate to heap just because value is known at runtime. Heap allocation only occurs when using box, vector, string, or RC. RC is some other type I don't know about, etc. The enum is stack allocated by default. So is it always stack, always on stack? I guess so. That's what it says. Question 2. In this match, like this, operation AB, what happens to AB? Is it borrowed? Is it moved? Is it copied or undefined behavior? I sort of chose borrowed, but it should be copied. But it didn't say copy over here. Moved or borrowed. So it gave us only two options, either moved or borrowed. So I sort of said something like numbers should get copied. If not, then I guess borrowed. That's what I said. And what it says now to me? Choose one. Important. F64 implements copy. You said number should get copied. If not, then I guess borrowed. This is fail. Rust does not guess. The correct rule depends on whether type implements copy, whether you match by value or reference. But you did not specify that in the answer. You said either move or borrow. That's what you said. Therefore, I got confused. Sorry. I should be more overconfident in what I claimed. Now, question 3. What is result F64 in string? Superior. Why is result F64 string superior to result returning just F64? Because sometimes we don't just return F64. And we want to say something like this is not happening, there is some error, do something with that. We want to send some string to the user also. Like because Rust requires no. Rust can work on F64 only because it prevents panic and model failure explicitly because the B option is correct. All right, so it's for me. Is it for me? So this question 3 is for me. No, I already answered one. So I guess question 3 is B. 3 is B. Now code review. Your implementation is correct. Minor improvement is that instead of error string from cannot divide by 0, prefer error cannot divide by 0 to string, not string from. String from is something that we use to print something like hello, or let's say we want to assign a variable some strings. So let's say let x is equals to, now how will we assign sort of hello to it? We can either directly say it's a string, just assign it, it will become a string literal, which will say static, and which we will get converted into binary, but we don't want that. We want sort of, let's say, mutable string. Now what? Now what? So for that to happen, we say something like, not like this, say string string, and then we say from, and then we cover it up like this. And that's how we define that x is a variable which has a value hello. All right. So instead of doing this, it's telling me that just directly they cannot divide by 0 and convert that to a string. So we'll do that. We'll keep that in mind also. C to B. Did not completely erase. Damn it. Uh, Not this. To this. To two string or two dash string. What was it? Two dash string. Capital S, small s. I don't know why they use sometimes small s, sometimes small capital S. It sort of became confusing after a time. Cannot divide by zero. Two string. All right. So more idiomatic and concise. Seems more idiomatic and concise. Yeah, it seems so. A deeper modeling question. That's all. We should try compiling it. It does not have much of an effect or dramatic effect. Yeah, it didn't have some drama. We got our results. The deeper modeling sort of MCQ is if we change function to calculation and then this we return operation. Then inside match we should operation AV. That's what we are doing. What are A and B now? F64? Obviously F64. It's F64 because they are copied. So there is no question number, so I'll say it's 4. Then I'll say A, F64. Think carefully. Now, final task before escalation. Test for division by 0. So then answer all MCQs in structured format. Just answer. Well, first and second were already answered, I guess. I guess we have to answer it again. I'm guessing too much, no? I should be just answering it. I guess. So now this is B. Or C. But I don't want to guess. So either I'll be correct or incorrect. What happens to A and B? It's copied. Now what? Now it's telling me final task before escalation, add test for division by 0. So either we can just do this, copy it and paste it. We don't want to. So I'll just implement it over there. But I'm seeing something interesting. Yeah, it's always like that. This bracket is closed over here. Yeah, it's not very interesting. We'll just written a new line. So I thought have something interesting. Let's open up assert. We are asserting equality between some operation and their results. So we'll say calculation and there is a operation OPE operation that is division, where we will say that we are dividing by 0. So let's say there is 10 and then the second number comma, use comma, second number is 0.0 or just 0. How about that? Let's do 0.05. What if there is some errors because of this? And then close the calculation bracket. Now we send error in the next line if we want to. Yeah, error is that cannot divide it by 0 to string, and we close that error and we close the assert equation, assert equality, or whatever it is. Is this exactly what we get? Like two string also. We also get two string. And it is interesting because I want it to, Just keep it in single line. And second thing I want to do with this is sort of yank it, uh, paste it. Instead of asserting, I want to see what happens. Print ln, print ln, and we do not send all these things with print ln. Close it. It's closed. This for this. This is for this. This bracket this bracket this. Yeah. I also want to see what will the output be. Now let's compile. Oh, we got an error. What is the error say? It is missing. Basic print manners are not present. Plus, there is no, sort of display that we have designed for this. So we have to use debug, but let's not use debug for now. Let's see what will happen. First of all, we did not add comma also. So we will throw an error. Let's do that. Add comma. Now this is good, but not good. Yeah. It says required by this formatting parameter. There is no implementation, FMT display implementation for result F64 and whatever we are getting. So let's not get it that way. We just use the debug mode and just use this instead. So finding our own display right now. Let's see. Yeah, did compile. Now fifth one. We'll get two outputs. Error. Cannot divide by 0 and okay, it's 8. Good. Good. Very good. And we don't see any messages from our assert. So everything is good. Everything yank. Not like that. Everything yank. Everything yank. Paste it over here. If paste it. Do it. Good. Now streak evaluation is your answer is correct. First one. So precise reasoning, your enum value is stored wherever it is allocated. In your case, enum is created on the stack. So two F64s live inside the enum value itself. No heap allocation occurs. Now, what happens to A and B? The answer is C. They have been copied. Yeah, they are being copied. You mashed by value. F64 implements copy, so value are copied up. No move semantic is triggered. If it was string, it would be moved. Now, question 3 was why result F64 and string? You answered that it encodes failure in type system and prevents silent invalid states and forces caller to handle error. We can handle error using sending strings, and we can just send our result using F64 if it is there. In this case, excuse me, in this case we are only getting errors and a string value that cannot be divided by 0. What next? The question 4, if function takes ampersand operation. So you answer A, that is F64. Incorrect. It is ampersand F64. Why? If you match, then pattern operation actually matches again against ampersand operation. So Rust automatically dereferences once, but the inner values are borrowed. All right. For match, inner values are borrowed. All right. So A and B becomes borrowed inside this, but in enum they are there. They are assigned there in stack. Because you are matching against a reference, to get F64, you need this operation add and okay, and the location to the pointer. We are pointing towards A and B's memory. Now, this distinction is critical for ownership modeling. Code review. Your updated code is correct, division by zero test is correct, no unwrap, and proper result handling. You are stable here. Escalation to ownership under pressure. Now we introduce the ownership stress, that is modify your function calculation to sort of get this to this. Now instead of sending type operation, we are sending reference to the type operation. It says do not clone, do not change enums. Implement correctly. Right. So I guess I can't copy and paste. Let's create. Since it's the same type, different problem. Let's create this. Now what? Let's create enum. First get into insert mode. Now let's create enum operation inside that curly brackets. Now add what? F64 comma F64. It is there. Now just yank it. Paste, paste, paste. All right. CW is div exit. CB is null exit. The CW is sub exit. We have created a enum. Now we'll create function called main, and we'll create some asserts and print. But right now I just want to print. But let's create assert for some now. Assert quality, and then we'll send something like calculation. Aside that, we were sending operation and then doing adding what? Adding, let's say 3.0 comma 5.0, and then we were getting a message called OK, and the value that is 8.0. This was a earlier assert. Now we'll create this one calculation and create OP, which is a type operation. So let's first of all do this, implement this, which is of type result. And in result, we are sending F64 and string. Let's just clarify some matches and logic first. Then we'll create it an ampersand. So we have a match that is matching the operation, and if it says operation OPERA operation add A comma B, we send A plus B inside a bracket. All right. This was an earlier logic. Did we use comma? Yeah, we did. We did use comma. Now there is another operation that is sub, and it subtracts A and B, passing A and B. It subtracts A inside a bracket, A minus B. Comma again? Yes. Third was operation of multiplication. Inside that we are sending A, B, and we were getting something A star B. And comma again. Is there something wrong? Yeah, operation spelling mistake. OPERATION. Operation. Everything seems correct. Now in operation, so div div A comma B. What we sent was if statement. Did we do it like this or something like something different? Like if B is equals to not triples, double equals to 0.0, what we'll do is not return. We just say that error and then not string from, we directly say cannot divide by 0. Then we created that for two string small, no comma used, and then we created an else statement which had a OK value and which just did A divided by B. All right, this is what we did. If we try to compile it, will it get compiled? Sure, sure should get compiled. Rust C. It doesn't. Why? There are certain errors that we are always prone to. So we didn't add toString. ToString is sort of a method or function, so we didn't add brackets. That's wrong. Operation, yeah, we didn't add OK to all the operations earlier. So let's do that. Let's do not this. So get into insert mode and say OK. OK. That's it. OK. Go back. OK. Go back. This is done. ToString is sort of function, so use brackets. I don't think there is much of an error now. There is, just tell me. Just tell me. Yeah, there is no error. Just warning. We'll run 5, 1. Yeah. 5, 5, 1, then whatever. 4. Let's. Yeah. Now we'll make the changes, like instead of doing operation and a type operation, we are taking operation as a reference, ampersand operation. So let's do that and check where all Rust C says we must make changes after just doing this change, not doing anything else. What it says. Let's see. So there are errors. Since this is operation, this is operations, reference, we must add the pointer now to the B and everything like that. Well, what is this? Calculation? Consider borrowing here. It's telling us some errors. Let's deal with them first of all. And instead of doing this, add ampersand over here. All right, we added ampersand. Now instead of getting A and B, we should get star of A and B. Not this star, star, that star, 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 star. Star is like pointing towards the location. Star. I guess it sure should work now. Is there any error? I hope so. I hope not. I don't hope for errors. Hope not. Yeah, there is no error now. It works fine, just fine. Let's run the compiler. Yeah, it runs quite well. Now let's copy it all, send it to our chat GPT that we worked it out. Given correctly. We do. There are also MCQs, so let's solve them. So first MCQ is, if we change ampersand operation, what happens to the ownership of enum? What happens to the owner? No, now it is borrowed. So it is borrowed, not cloned, not moved, just borrowed. It is not, no, it is not moved. So yeah, it is borrowed, and then enum value remains owned by the caller calculation, only receives an immutable reference, no move occurs. The implementation is also correct. You matched operation, ampersand operation, that is reference AB and became ampersand F64, which is dereferenced with, yeah, this is dereferencing the pointers, not referencing them. This is referencing towards the pointer, that there is a pointer, go towards that. This is dereferencing a pointer. If there is a pointer, we get the dereference to it. We get back the value instead of getting back a pointer. Earlier, this A and B was just sort of a pointer, not the actual value. So no clone was there, no move was there. Good ownership is handling, a good ownership handling, and now we escalate. We introduce partial move semantics. Concepts like partial move. So if there is a user structure which takes a name and a string of their respective types, that is, name is always string, and age is sort of a unsigned integer right now. I don't know why unsigned. Uh, I guessed in the morning that unsigned integer can never be negative. If we try to do negative operations with unsigned integer, it always throws error. We can only do negative operations with the signed integer, that is I32. So that's why I think age can never be negative. So we are using unsigned integer. I don't know the perfect reason why are we choosing unsigned integer. Let's ask it. If it answers me, good. Doesn't. Uh, how do we know which type to choose from? Like, there are SIGNET integers and uns SIGNET integers, signed integers and unsigned integers, like I32 and U32, I8 and U8, like so. All right. Now it's telling me to create a main which has a variable which we assign it to the structure user, and now we create the name using Raj. Why can't we use toString instead of using string from Raj? I guess that's what we use while no giving it a variable string. That's what we use as always, and that's what I'm guessing. I don't know for sure, but that's what we have done from day 1 to day 4. I guess it's day 4 for me. Now age is 25. Nice. And then we say that let name is equals to user.name and print the username. But it is out of scope for this. Out of scope for this. This is the scope starting. This is the ending. So will it do this operation? I guess so. Because this is owned by this, but it is getting assigned in the structure. So we can use structure over here also, even if it's outside the scope. So let's say what's happening. This is question 1. Let's say question 1. And then what's happening is we created a structure called user, and then in main we are passing it a value, then out of scope to the value we are asking question about its name. It should compile because struct has the ownership to the value, name, and age. Ah, yes. Question mark. What happens here? Works fine, compile error, like partial move, runtime panic, or something else. Will it work fine? According to me, yes. So A, work fine. Question two. Two. Why? Because U32 is not a copy. What? So we are not printing the name. We are printing user's age, but we are calling for user's name. If this happens, this can happen automatically. If this happens over here, like user.name works, then this should work also. If it doesn't work, it doesn't work too. Now what? Because U32 is not copy, because string does not implement copy, because struct field cannot be moved, because println moves everything. String does not copy. So I guess this thing will not compile. I don't know the reason. I don't know the direction it's going. Let's answer something. Let's say C. 3. Implementation task. Write a minimal program demonstrating the partial move error. And so it is a partial move error. So this should be the answer to it. Since I don't know what the partial move is, let's do it. Write a minimal program demonstrating partial move error, fix using borrowing, and fix using ref in pattern destructing. Example like let user then refer to the name and age is equals to user. Do all three. Like failing version commented, borrow fix, and then ref pattern fix. No explanation yet, only MCQ plus code. We escalate only if precise. All right. Let's first see that the direction we are going is fine. It's definitely wrong, but let's see. Good. We pause partial move. First, we answer your new foundational question. How do you choose I32, U32, I64, etc.? It is a system level design question. We formalize it using MCQ. Step 1, signed versus unsigned. When should you choose? I asked you and you are asking me back. When should you choose unsigned U32 over signed I32? A number is always non-negative. Yeah, that's what I guessed. When you need negative numbers, no. Performance is better. Memory is cheaper. I don't know. One ka A. An important principle is unsigned is for size, count, and indices, memory offsets, and signed is for mathematical values, differences, values that may go below zero, that is negative. Yeah. Now step 2 is a bit width selection. So what determines choosing I32 versus I64? Random preferences of CPU architecture, maximum possible range of the value, the compiler default. I guess the maximum range for the value, maximum possible range for the value. If you want something big, we choose big I64. If you want something small, we know will remain small. I32. Like there is, in C there is something called integer or decimal, or then there is something called long decimal or long integer. It is represented by, see, normal decimal is represented using D and I for integer, and long decimal is used like LD or LI. So I guess that's what it is, either it or I64. It's specifying using the size. Now, core root. Choose the smallest type that safely fits your value range, but do not micro optimize prematurely. Why U size exists? That is, why does Rust use U size for indexing? Because it is always 64-bit. It matches pointer with width of the machine. It's faster. It avoids overflow. I guess the B is correct. I don't know why U size is used. A key principle is that U size is pointer sized unassigned integer. Unsigned integer. So pointer sized but unsigned integer. So what I chose right now is, yeah. So on 64-bit machine, it will become 64-bit. In 32-bit machine, it will become 32-bit. So it matches addressor space. That's why I chose. Now step 4 is ML context. Now for indexing into large numpy like buffer in Rust, which is most correct? I guess U size. For indexing into large numpy like buffers in Rust, U size. C. Now back to partial move. You answered incorrectly. Yeah, I thought so. This does not compile. Yeah, there's compile error partial move. Now question 2, correct? Because string does not implement copy. When you move user.name and string is moved, now user is partially moved and you cannot use user.age afterwards. So we first use string, so it moved, and now user is partially moved. So now we can't use user.age until and unless we end or drop user.name, and user becomes, I guess, invalid or goes back again. All our answers are correct. Now the integer type intuition is now aligned with system design principle. Now back to partial move. Ownership under pressure. Now previously answered incorrectly about struct example. Now we enforce precision. Like given there is a structure, this, and main is again this. We are creating a user and then calling a user.name. So here, since we are calling a string, it will drop this user to over here, and then the user.age becomes invalid. That's what it explained earlier. User.age becomes sort of unfamiliar. From user name, this value gets moved, partially moved. That's what he told me, to the variable name. So now this user is locked, yeah, to this name, or partially locked. And now we cannot access user.age until and unless we let this variable name let drop back. So this does not compile because user.name moves the string. It moved the string from user name from here to here, this name. Now string is not copy. It moves or it takes reference. So user becomes partially moved. So you cannot partially, why? Because we do not move the age. So, and we can't move age. We copy age because it's a number. User becomes partially moved, so you cannot use remaining fields. This is called partial move semantic. Now MCQ is that MCQ round, that is straight. Let name is user.name. Now what is the state of user? It's partially moved. Now let me add something so that it can clarify me. Why partially? PIALLY, because age was not moved. It can't be. It can be copied. So this is what I think happened. That's why partial move. Now question 2 is why user.age is still accessible in theory, because U32 is copy. So 2 का answer is U32 is copy. Now question 3. Why does Rust forbid using user after partial move? To avoid double free or to avoid user after move? Use after move. Because compile, I guess double free is the answer. How about we just use, name, and we then tried freeing the name. So then user.name, the pointer over here will get sort of freed. And then when this user gets deleted and tries to free the name back again, it's double free. So we'll try to avoid double free as much as possible. So I think this is the answer. Now implementing task required, implementation task. Write a small program that includes trailing version that is commented out, show partial move error, and then borrow fix, which is take it by reference so that you cannot free it. All right, I'll do it. What it's saying me is to create that program that we were seeing for the past 2 minutes. All right, I'll do it. Since it's a different type, we'll name it 6. Now, what else? We need to create a struct, struct, that is user. Inside that, we get name. It is of type string, and do we use comma? I guess so. Then we get age, which is of type U32 unsigned because it is positive, and 32-bit because we want to. Email, no email. Now in fn main, in function main, what we did was we said let small user. It's not the same either. We assigned a value from user structure, and then we are calling the value. Let name be something like string from, and then we use name, say Alice. That's what it's suggesting me. Now I sort of want to add my question also, so let's comment it out. Why not use this what ALICE and then 2 S, small s string, 2 string. Why not this instead of, no question mark first of all, instead of, sorry, instead of string. Now we'll create age. We'll give her a value of 30. She was 30, 18 I guess. What is the age? 25. The name was Raj. That's my name. 25. Let's do that. Oh, there's an error. What? We used this thing. Do we use comma? Do we use comma? We do. If I guess correctly, we do. Yeah, we do use comma. Not full stop. Not full. Array. And this back again. Replace this with comma. Append a comma over here. Then what we tried to do was, what we said was there let be a variable called name, and then we told it to get a name from user, and we got a name from user. This was wrong. This was wrong. Clearly wrong. It's getting not colored. See, this is the correct implementation for borrowing it, and second of all, you do not add semicolon. And then we try to print ln sort of age. Let's do that to user now age. That's what we try to do. If I remember correctly. Now let's try compiling it. Just see. 6 yeah, there are errors like first of all there is a semicolon. Unexpected one. No. What is so unexpected about it? I guess over here. Maybe. Let's see. Let's see. The real program. Yeah, there was because user is getting something. User. And then user.name and user.age. It's exactly like ours. Yeah. No spelling mistakes, nothing. Will it get compiled? No. It did get compiled. Done. If we try to print it now, we get 25. Shit. Now, and J, then we'll paste it up here. We'll say, oh, that. This also got compiled and ran. Compiled, PILT. How about this? Now we use ampersand, like by reference. What happens now? We'll get an error. We don't get an error. Anyways, and let's take it by reference to. We should be taking age by reference. This is so wrong. Let me do it. This also works. Everything works here. Interest. How does it say? Why? Well, it said this does not compile. Well, what you know, ChatGPT, it did compile for me. What the hell, guys? We have a problem when it's not compiling. We have a problem when it compiles. We have a problem everywhere. So now question 1 is correct. I answered C, which is correct. State of user is partially moved because name is field moved and age still present. Now your answer 2 is also correct, which is copy, that util2 gets copied, not get reference that we did over here, and still not get any error. I don't know why, but I don't know yet. Is this a stupid or what? You answered A, to avoid double free, not precise enough. Correct answer would be to avoid use after free, after move. All right, so after moving, we cannot use back again the user.name. The primary issue is not double free. The issue is that user is now in an invalid state. Some fields are moved, some not. Rust prevents the user to use after move. So double free prevention is related but secondary. Now, important observation is you wrote This also got compiled. This is correct. Why? It compiles because you're not using user again. What? All right. So if I use user again, it will not compile. You're only accessing user.age directly after move. This allowed because age is copy, it was not moved. You are not using the whole user. So this would fail. So what? It's telling me this would fail. Let's see what would fail. Instead of user age, we just want to print user. Since user is of it's of type something we have not implemented. You have to say derived debug, but let's do without derived debug. But we will need to do that. It says derived debug. Let's do that first of all. One, not I, one. Not over here. Shit. Capital. Derived debug. Right? It says debug. That I'm using. Yeah. Hmm. Array. What the hell? Yeah. It got compiled. It got it got compiled, yeah. Damn it. What the hell? Chat GPT is so wrong right now. What do you know, Chat GPT? It got compiled. I mean, I need to troll Chat GPT right now. Get the whole thing. Yeah. Good. It's saying good. Now we slow down and analyze precisely instead of reacting. Your current code is this. This compiles correct because you borrowed user.name. You did not move it. So user remains fully valid. Immutable borrow ends after the last use of name. So there is no partial move here. An important distinction is the failing case is this. Yeah, that's what I did. See, here is your failing case. You know, is there any difference between them? I don't think so. I don't think so. But this compiles. Why? It's telling me this compiles. Why? Because age is copy. I am not doing this. I'm not doing this with this. I am saying that this also got compiled and I got an output. Where's the output? Come to me. You damn output. Let's show ChatGPT who the boss is. Ah, and now what? Now what, GPT? Yes. It's telling me sometimes it's incorrect behavior, and now it's telling me it's correct behavior. That's why we shouldn't trust these GPT models right now to write our code in Rust, especially because this is not partial move. It's immutable borrow. Wow. Ah, so it's not ChatGPT that was wrong. It was me. It was me who was wrong. Sorry, GPT. I roasted you so bad. It was my issue, my skill issue, not GPT's. Now this will not work. That's what it's telling me for past 3 hours. All right. Yeah. Yeah. As expected. Thank you. So, it was correct. I was. Uh, what a surprise. This compiles and this does not. This also. This C2W. This does not file. And that's what we expected because the user is in partial move from right now. Compile, that's what we expected because user in so many spelling mistakes. Replace it with O W H A T because the user is in PARTIL, partial move from right now. Is correct? Hello? Yeah. Will this compile? No. Question 2 is no. But let's answer this question now. Now we understood, so we'll answer this question now. Alright? Ask me some questions. Case 1. Borrow is valid. Partial move, invalid. Partial plus whole structure error is this. Does not compile. Valid. Partial move, field allowed access. Let's store it. Let's store it. Where? In the program itself. We will store it over here. Tuck, 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 tuck. Storing this. Huh? What happened? Yeah. Took some time, but never used to take this much time. You know? How about set wrap? What? No. WRAP. Wrap. What happened? Ah, see, since I use the terminal, there is Control Shift V or Control Shift C for copy and paste stuff. But in browser, it's just Control C. That's what you know, that's where I get stuck. See, does work. So now, to answer the MCQ. Question 1 is, what is question 1? After let name is equal to user.name, then print user.age. Is user fully usable? No. No, no. 1 ka B. 8 is PARTIALLY, partially. Now, second, will this compile? No, no, no. Damn no. It will throw an error. Now we know. No, no, now we know. Now, question 3. Why does Rust allow user.age after moving user.name? But because age is a copy. And what is C? Rust tracks ownership at field level. I guess D is the answer. Everything is correct now. You understand partial move, leave structure, copy. Good. Now we apply pressure, mutant, or conflict. This is where many people fail. I don't care many people fail or pass. Let S is equals to string from hello. Yeah. See? I asked one more question. I asked one more question, which was I asked one more question. Barlir. Answer this too. Then we'll move forward. No. Wrong thing got copied here. That's what I want to copy. I want to ask this. But let's still read this through. So case one, array root. Let's read it. That case one is a borrow, where we are taking it by reference. So it compiles, no ownership transfer, user remains fully valid. User reason is that user.name creates an immutable borrower. So user is not engaged, it's not partially moved. So no field is moved, borrow ends after last use. So NLL, that is non-lexical lifetime, and structure remains intact. Now case two is partial move, where we use username and then user.age. Now user is totally used right now, so user cannot be used again. So user as a whole is unusable because it is partially moved. And individual unmoved field is usable, like the age and stuff. Now why? User.name moves the strings, which is like moves the user.name, but user.age is a copy, so it remains accessible. So user is partially accessible, so it's partially sort of moved or partially accessible. So Rust tracks ownership per field. Per field, like one field is name, one field is age. So it tracks ownership per field for each field. Now the structure is partially invalid. You cannot use user itself again, but you can use user.age. Now subtle but intentional. Now case 3 is partial move, that is whole structure usage. Now it says that print ln and then debug mode user. This will not compile. Why? Because user requires accessing all fields, but name has been moved right now. So structure is in invalid state. And now compiler prevents use after move. So deep rule, very important, that Rust tracks ownership at variable level and field level inside structure. So when using the entire struct like debug print, Rust need all fields to be valid. If even one field is moved, whole struct is unusable. Now I test precision. Like question one is partial move. You can use question one is yes, yes. Then what is question two? If we write user name comma age is equals to user, what happens? What happens? Let user and name is equals to user. What is user? Compiler, I guess, both field moved. We are assigning user to user. How can that work? Both field moved. Compiler, I guess. Yeah, D. 3. If we write, now I'm going to take some break after this question. No? If we write this, ref is equals to user, what will happen? I guess B. 3 is B. All right. Submit it. But we will not see that right now. No. Come on. Oh, yeah. We want to first resolve this. I'm taking a break for a few minutes. So mm, So hello back again, and I've taken my break. Now let's go. The time is 10 o'clock right now at night, 10 p.m. Mm, I asked some question about why can't we use two string instead of string from Alice. Now we'll see why is that reason. Why is that the reason? And we answer in a strict system terms. Now question is why use string or from Alice instead of a two string? Are they different? Short answer is they are effectively equivalent for ampersand str. No behavioral difference, same allocation, same resulting string. What actually happens internally is for case one like string from and then getting string, that's Alice. Now this calls for this function or this implication. Is this implication? IMPL. This is implying something, no? So this implication from ampersand str for string, it allocates on heap and copies the byte. Now case 2 is that Alice and then two string. Now this is two string trait, which is like implementing that T for display, two string for T, and for ampersand str, it internally calls the same thing. All right. So instead of doing, converting into string, it's calling string from for self. So it is sort of like to string, which is going from string from and then creating a string. So instead, why not use this? This might be a shorter way, but there is no difference. So which is more direct for converting ampersand str to string? I guess this one. Now abstraction level, both are identical because to string is also calling this string from. So yeah, but I'll go with the option A. All right. Now what's question 2? Which one works for any type implementing display? Which one works for any type implementing display? I guess this one. So 2, B, or both. But I'll guess this one. But this one also worked. So I don't know. Both. C, both. And so third one, which allocates heap memory? String from. No, both does, but the two string also uses the string from. So yeah. Idiomatic preference in Rust community, the string from text preferred when converting from string from ampersand str, and to string is common but more generic. Both are fine. Performance identical for ampersand str, no meaningful difference. Answer MCQs. And what is it? Oh, it was not the answer for this one. It was answer for the previous one. This is the answer for this one. So it's telling me first is A, second is B, so not C. So correct answer is two strings work for any type of implementing display like this. X2 string works, but from 42 string does not compile because string from does not work for arbitrary display type. All right, so no need to answer all these. Which allocates heap memory? I answered C actually, but all right. The summary is whatever it is. Now, concept reinforcement, very important, that string from ampersand str, which is specific conversion, and dot to string generic, which works for all display, and both allocate for ampersand str performance is effectively identical. And now we return to ownership pressure. The mutable borrow conflicts answer all these MCQs. So why does this fail? So there is string from hello, and then we are taking the mutable reference of we can't take two mutable references, yeah, simultaneously. So one answer is T. I guess I learned it on first or second lecture using ChatGPT only. So now day two, question two. What rule is enforced? Many reader or one writer? Yeah, this is the enforced rule. Many reader or one writer, not both simultaneously. One many writer, one reader. No. Will this compile? So what is this? This is mutable s, which has the value hello. It is a variable string. Now there is a let r1 that is taking a reference of mutable s. All right, and then it is printing r1. Yeah, this works. Now there is mutable r2 in a different sort of scope, and this is also taking a reference of s. Yes, it works. It works fine. It works. 3. Yes. What is s? Option A. So answer only. All right, I answered. All correct. Question 1B. Huh? Did it get hanged somewhere? Let me ask. So how much is left to select? Good question. I will answer precisely. You're asking how much is left or how many mutable reference can exist at one time. No, I didn't ask this. How many mutable reference? Exactly one mutable reference. Visual is this, not allowed, not allowed. Important details. The restriction is at the same time, so this compiles. R1 ends here, so this compiles. We all know because R1 lifetime ends before R2 begins. MCQ precision test, is this allowed? Not allowed. 1 B, not allowed. What is second one? Now second one is B. Second is this allowed? There's a all right, all right. Is this allowed? Now this is tricky. There is one reader and one writer. Both cannot simultaneously occur. So no. Either there should be one multiple readers or one writer. Both cannot occur simultaneously. So no. My answer is no. There is no option N. It is B. Sorry. Yeah, B. No. Why does Rust enforce this rule? To prevent data race? Yeah. To reduce heap usage? No. To increase speed? No. To simplify syntax? No. So it is to prevent the data race. What's data race right here? So let's say R1 is trying to read S very fast, and let's say it's happening in loop. Whereas R2 is trying to mutate whatever this hello is. It's trying to say hello world or something. So R1 just read hello, and now it has to read hello world. So this is the data race. Who reads the hello first? Who reads the data first? Or who writes the data first? So this is the race between these two. This should not happen ever in Rust. This makes it so unsafe. And I wanted to ask, how much is left to cover in Rust? We also have to give the Python for today. That's what I want to ask. How much? Right. Good. First, we correct the MCQs. This is incorrect. So you answered B. What I answered B. Is this allowed? This is allowed. Yes. This is allowed. They are both reading at the same time. So no one is racing each other. They both can read. There is no problem. So I guess I wrote something wrong. Correct answer is A. Yeah, I know. This is correct. This is correct. Now, current Rust progress today is we have enum with data, match destruction, result, uh, borrow. Oh, we have much left. Source of partial. We did this field level ownership tracking, mutable borrow, conflict rule, and NLL intuition, then string conversion nuances and integer type selection. What remains for day 4 is we have covered these many. All right. What remains for day 4 is the Rust side, trade fundamentals, generic function with trade bound, and default trade optional unit test module. And this is 2 to 3 focused hours done rigorously. What we have is 10, 11, 12. We have 2 hours. Python for remaining days, 2 hours. So it will take, oh my, we can finish the abstraction first. Let's finish it here. Let's finish. Quick. Good. We now enter trade foundation. This is where Rust becomes a system level language instead of syntax language. System language instead of syntax language. So what is a trait? The first principle from first principle. Trait defines behavior, not data. So the structure defines the data. Enum defines the state variation, whereas trait defines the shared behavior. Think like trait is a capability contract. So example is trait is describable. So fn function there is describe and it takes self which returns string. Now this says any type implementing describable must provide describe. Oh, so any type that is trying to implement describable. So describable has a trait called describe. So it must describe itself first. Now why trait exists? Without traits you cannot write generic behavior over different types safely. You cannot write generic behavior over different types safely. Traits allows static polymorphism, zero cost abstraction, and compile time dispatch. And type constraint that is generic. Now, static dispatch is important. Static dispatch is when you write a function called print description, and it has a t, which I guess is an what is t? A vector or array? I guess it's a vector. T or a type which has a describable type, and it requires item with a reference of t. I guess the function name is print description, and it has a type of describable, and then item it takes is the reference of t. So Rust generates specialized version at compile time for each concrete type. This is called monomorphism. No runtime cost, no virtual table, no dynamic dispatch. MCQ round is trait concept. A trait defines data layout, memory action, required behavior, lifetime data layout, memory allocation strategy, required behavior. Like describe, print describes, required describable. So one is required behavior. As for two, what is two? Trait enables runtime inheritance or state polymorphism. Yeah, static polymorphism, not state. Yeah, static polymorphism. So two has an option of B. Let's say B. A monomorphism means trait method run via dynamic dispatch. No. Trait uses heap indirection. Trait uses macro. Traits are macro. Generic function are compiled separately for each concrete type. I don't know. 3 B. I don't know. Let's move on. Answer first. I did answer. All good. You should not say I don't know there. That concept is critical. Monomorphism is the reason Rust have zero runtime overhead. Rust generates print description for user, print description for operation. at compile time. No vtable, no dynamic lookup, direct function calls. All right. Now we implement step one is that define trait. So we'll create a trait called describable, which will have a function called describe. So we'll have to create describe to implement describable as a trait, and then implement for users like user, then string age u2, age u32, and then we'll implement describable for user, that describe first string which has a format user, then this self dot name and then self dot age in this format. Now what that will do is step three, implement for operation, and we'll implement this for operation. And step four, generic function with trait bound. We'll create a generic function with trait bound, call with both user and operation. So before you code, let's answer some questions first. When calling print description use and ampersand user and print description and percent op, Rust uses dynamic dispatch, virtual table, no virtual table, generates specialized version at compile time. Yeah, box is the value. I guess C is the answer. I don't guess. I know the dynamic dispatch tag. No, it's not dynamic. So question four, and then post full working code. So we'll create it in a same code, let's say. So step one is, first of all, create a describable, and then for user, we'll implement describable. For operation, we'll implement describable, and that's it. And then step four is generic function with trait bound that calls call with both user and operation. Call with both user and operation. How can I call them? So let's do what we can understand for now. What we can't do is we should not care about. This is a new type, so we'll create not very new, but yeah, new concept. So it's telling me first of all, create a trait, TRAID trait, and the name of the trait is describable. DESCRI, describe, BABLE, describable. Spelling is spelling is all good. Describable. Yeah. Then there is a function describe, which takes self and returns string. Then there is a function called describe, describe, which returns the self and returns something of type string. Is it good? It seems like this ends over here. So we created, step one is done. Now step two is that implement for user. First of all, use, use the structure equal to user. Then we'll create an implementation of use not use, no. Yeah, struct user. That's what I thought. There's something wrong. Struct user, and then we'll create it for name, which will be of type string, comma. And then we'll create for age. There's something wrong because yeah, u32. string string. And then see in some struct capital S, small s. That's also the second problem. Struct. It's all done. Now we have to, oh damn it, we have to implement for user. We have to implement trait. The trait is describable. DSCRI, describable for user. What we'll describe is, first of all, to have describable traits, we have to describe the function. So this type, what it will take is ampersand self, I guess, and what it will return is string as predefined, string. Then we'll create a function where we'll have a format. It is a macro, I guess, format, and inside that we'll have user, and then ending. No, this is not what implemented. This is what we implemented. So we'll get a user, then name, and then we'll get in a bracket the age. So yeah, so we'll get self dot name, and then we get self dot age. This is how we describe it. We don't need any semicolon over here, I guess. Self dot name, self dot age, everything seems nice. Self dot name, self dot age. It's just it doesn't get colored. I don't know why. Describable, no spelling mistake, nothing. Seems nice. So seems that our step 2 is complete now. We'll move to step 3. It's telling us to implement operation. So step 3 is to implement operation, which is enum. So we'll create a enum all called opera operation, and like operation add, we'll add something add. What type of operation? Yeah, this type of operation. So yeah, it's like F64, comma F64. There is also some doubt, like why do we sometimes use angular bracket, sometimes we use circular bracket, but that's for sometimes else, because we need to cover up soon, otherwise we'll be late. Instead of writing, just make it paste it, paste it, paste it. Then CW is dict I MUL, sorry, CB is SCB sub. So there's sub, multiply, divide. That's it for our operation. We have created enum operation, and then we need to implement describable for this operation too. So what are we describing? That match the self from here. We are providing operation in the cell, and then we match if operation is add, or if it's add, then we add. And oh, we don't add, we just say that add this and this. If it's subtract, we say subtract this and this. Why is this even there? Like, what's the use of it right now? I don't understand it, but it doesn't mean it's useless. I hope so it's not useless. We're learning it. There's so much of a mind capacity right now. What operation? No S, so operation. Then we have to describe DSCRIBE. We are describing. What we are describing is ampersand self, which will take operation self and must give us result instead of string, or will give us string. Yeah, we are not creating the result right now, and it should always take type string. Now we create a match ampersand OP or OP. We just match the self, whatever the self is. And inside that match, if this is operation add A comma B, then we say, format it like, we mean, yeah, A degree add, this is A, and This is B. So we've described it. Now we mentioned it that A and B. This is how we did it over here. Yeah, exactly like that. Now we'll just yank it, paste it. Same thing for sub, and then we you know sub TRAC subtracting. C is nice. Not subtracting, subtract. C3H. I improve my Vim skills. Subtract B from A, not A from B. Replace B, replaced by A. Alright, seems nice. Now step 4 is to create the generic function with trade bound. I don't know what it means. And call with both user and operation. How to call that? I don't know. So let's just type it out. And there is no main function over here. So let's also create fn main. Fn main. What it does, I don't know. Nothing. Let it pass. And before that, we will say fn print describe or what? Yeah, print description. We'll take item, not item. See, we use angular bracket. Why? Nobody knows. So print description. So we had T, that is of type describable or describe. I don't know if there is any spelling mistake, but there is not. But still, it is not getting colored. So I am getting anxious because we don't know what we are doing right now. We are just copying and pasting using our hands. Describable. T is describable. That's it. Describable what? Item. What item? Item is of type ampersand T. Is that it? Yeah, I guess. When we go here, we say print ln, not print ln. Then what we are printing item describe, item dot describe. So whatever got described, we are just printing that. So printing item that is being passed for us, dot describe, item dot describe. It's a function also. Is it all right? Item dot describe. Since we are printing it, I don't see much of an error happening right now. There's one. I got one. In item is of type. I wrote L. It's a typo. And then it's telling us to call both user and operation. Call with both user and operation. So we'll call both for both user and operation. We will say, print and description for, we'll say user, and that's it. And then we'll say print description for operation. Shall we specify as operation add or what? Or we just call it for operation? And for users also, do we have to add the name and age, or we just call it? But it said describe cell.name cell.age. This will throw us some errors for both user and operation. So let's try and run it first. See 7.rs. Yeah, there are errors. So what's telling us is it should be something like ampersand multiplication also, because yeah. So did we cover? We didn't add multiplication and division, so no need to cover it up. Uh, 2GCC. Yeah, that's it. Solved one of our issue. Now rest is what is it? Yeah. So we need to add fields for add subtraction. So it must be same for user too. So we also have to add, uh, in this call we have to add user name, and then how do we pass users their name? We say user, and then yeah, should be something like this. So let's say name. See, Copilot is suggesting us right now, so we'll just use it. List, and then we convert that to string. We can just use something else. And there is age, which is 30, 25. It's 25. As for operation, yeah, we are getting the suggestion, so we'll just take that suggestion. Now I think we shouldn't have much of an error. We are not taking it by reference, whereas it shows that this all thing is taking a reference. It is not taking the whole thing, it's taking it by reference. So let's add the ampersand so that it takes it by reference, not just takes that only number of whatever it is. Now what? Now there is a bigger error. It is telling me that there is some structure over here. Ah, is it? Let me see. First of all, let me see, 6. Let me see users. So how we added name? We said user and then bracket and then name and age. That's how we added. How we are adding over here is user. This is the X. Remove it. Remove it. I guess this is fine now. Now what? Two string. What is this? Let's remove this at I did a spelling mistake. Spello. Typo. To ST. Oh, just ST. Insert R. STRING. Now what else? There is no comma. Where? On line 26. Let's go to line 26. So there is no comma. There should be a comma for both of them. Let's add comma for both of them. Add comma, then add comma over here too, just to be safe. Now what? It runs. It runs. See, we make things run. Yeah, we made things run. So now we are getting user is Alice, which is age 25, and then add 3 and 4. We are not adding stuff because that's what we wrote. So let's, instead of 7.rs, we cat 7.rs. Then, sorry. I'm very, very sorry. Why? Yes, I could have just copy, then we paste it, output. As for, you know, over here, I'll mention cat 7.rs, and here I'll be printing out. So how? We'll just call 7.rs, rs, and we'll copy the whole output. And we'll just go and paste it. Not Control Shift V, just Control V, but it works. I don't care. Yeah, so question 4 is correct. Compile time is 1 hour. So your program is correct. It compiles and produces expected output. Trade implement properly. Generic bound used correctly. Static dispatch in effect. So precision review is something like everything is structurally correct. Minor stylistic refinement is user describe. Inside user describe, let's open up unit. Let's see side by side. What is it talking about? Say not ours. Ah, so inside user describe, is it here? Yeah, let's see. What is there? Format, user, everything. What is the error? Self.name, self.age. This borrows self.name automatically. No move occurs between format and tail display. So what is the issue right now? Ownership is preserved. This is correct. Thank you. What do you want from me? Just tell me that. Ownership is preserved. Correct. Now we deepen trait understanding. We escalate default methods to method resolution. Now we deepen the trait understanding. Now we escalate the default methods and method resolution. So add default method. So it's telling me to modify the trait that is describable from describe to a short name that is generic. Now all type implementing trait automatically gets the short name unless they override it. All right. So what it's telling me, I don't have to create another program. I can just do this. Is it a function? Yeah, it's a function called short name, which takes first of all self and gives out a string, which is a generic. It returns a string that is generic. So this is the generic name that is being returned. Not quit. Just save it. Yeah. So here's an implementation. Just the spelling is wrong. short. I am just excited and very. I'm trying to write something fast. I need to complete this very quickly. Now, step 2 is override in one type. So it's telling me to override this short name function in one type like user. Do not override in operation. It's telling me go in the user and override this short name function. User. I did something wrong. I implemented this describer for user, not over here. I should be describing it over here. I guess so. Yeah, see, it is a trait describable, not implementation. So let's first of all copy 3. Nahi, behind 2j. Behind still 3 lines. Come over here and try pasting it. Yeah, I guess it's correct. Extra brackets, nothing at all. Just extra line above. I want it. As for here, I want to override short name for user. I'll say how will I override a generic to sort of overridden. Will this happen? Or is this good? Is this good enough? Is that we wanted? Yeah. Like, tell me, is this good? Tell me, yaar. All type implementing trait automatically gets the short name unless they override it. How to override it? Ah, so it's telling me how to override. Override in one type. So it's telling me go in, short name and user over here, and then take the self instead of take this string. We say reference of string str, and then what happens over here? It says self dot name, and then it's overriding it. Self dot name. All right, so it's not overriding this generic by overridden string. It's overriding it by saying cell.name, let's say. So let's uh, I'm saying cell.name. See, it understood automatically. Do not override in operations. We did not. MCQ run. So if operation does not, first of all, try compiling it. If it compiles, everything is good enough. So compile, rust, C, 7.rs. Ah, there's error. Thank you. The expected string found ampersand str. Generic to string. So I guess we have to. Ah, so we have to either do two string, or we can just change its type to ampersand str. All right. So instead of having a type called string, we can change it to ampersand str. Ampersand str. And this should work. Yeah, this works fine. Now let's print it out. Yeah, ls and then whatever. So now what? Now everything works. Let's answer its MCQs. MCQs passed. So if operation does not override short name, what happens? If operation does not override short name, what happens? Compile error? No, no. There is no compile error. Use default. What is this? This is a warning. So, what is this telling me? Method short name is never used. Describable trait short name is never used in operation. So subvariant sub is never constructed. All right. It's telling me short name is never used. It has been. If operation does not override a short name, what happens? Nothing. Uses default implementation. You know, 1B. What's second one? If both traits and struct define a method with same name, which wins? So if both traits and struct define a method with same name, which one wins? Uh, I don't. This is a new question. I guess trait will. I don't know, because the trait carries a wide weight. Like trait is for mostly everyone. If we implement trait for everyone. Three. This call the user dot short name uses static dispatch or dynamic dispatch. It's a dynamic dispatch or heap lookup trait object. This is definitely not a trait object. First of all, it's using a dynamic dispatch because we have used user, okay. So it's a B. I don't know. I might be wrong. Implementation task is modify all your program. Now, all modify your full program. All right. And add default method override in user print both. We have never. printed it. That's why we don't see much of a change. Main, where is our main? Main, come over here. Now in main, we have to create this. We have to paste this, not like this. You go like insert and then press tab. Everything is done. Come outside, compile it back. Ah, what is it? The user.short name is not found in this scope. So what? So what? So what is it telling me here? Override in user, add default method, modify a full program, then add default method, override in user, print both. MCU update full program. Then Rust core today is complete. Then we move to Python. Aha, what is the? Let me see. Let me see. I can understand something. So this is first of all user short name doesn't work like this. Ah. What about if we yank it from here? Where is the user? Where is the user? Implementation for describable. We are doing this. Match self, match to. So we are printing, item.describe. How about we just, paste and print item.shortName? How about this? CW item.shortName and just do what? Do GCC comment out. Now we are good to go, I guess. Not enough. It needs what? There cannot be two return values, no? What's telling me is remove this first of all. Now what? All right, we'll add this for both. What now? Yeah, it compiles, and since it's compiled, let's see. So user is Alice, and we get user uh, name that has been overridden by Alice, and then we get generic for operation. And I think we are good to go. That's what this ChatGPT wanted from us. I guess so. This is it, and we'll then copy our 7.rs. Good. Programming is correct. Output confirms the behavior. Now strict evaluation is MCQ evaluation. So first is operation does not override short name. You answered B. That is correct. Now what? In both trait and struct define method with same name. Yeah, depends on how called. All right. So this is the correct answer. Because I didn't know. Explanation is if called normally like user dot short name, the implementation in IMPL describable for user wins. All right. But if you use fully qualified syntax like describable, short name, and user, explicitly called trait version, Rust allows disambiguation. This method resolution control. This is method resolution control, and I don't know about that. Now, question 3 is this call that user.shortName is a dynamic dispatch. I thought so, but it is incorrect. It is a static dispatch because user is a concrete type, so no dynamic describable and no trait object. And monomorphized at compile time. So dynamic dispatch only happens with a function f, and the item is a reference of dynamic describable. Now you're using generic bound static dispatch. So summary is: one is correct, two is C, three is A. Important, do not confuse trait with runtime polymorphism. I'm totally confused, but all right. I have to reread it, everything, basics. But now I don't have a time. We have to also, cover a Python. MCQ is very important. Like, when does Rust use dynamic dispatch? When T for trait or dynamic trait? Ah, 4 is B. It's very clear because that's what it told me right now. Why are trait bound zero cost abstraction? Why are trait bounds zero cost abstraction? Because Rust deletes trait code. Why are trait bound zero cost abstraction? Because Rust deletes trait code. Or there is because of monomorphism, or because traits are macros, because compiler ignores them. Why are trait bound zero cost abstraction? I don't know. Because Rust deletes trait code, because of monomorphism. Trait are macros, the compiler ignores them. I guess B. Answer for 5 carefully. After that, the Rust core for day is complete. Then we move to Python memory filing. Right. No rushing. I am rushing. There's only 1 hour left. It's 11 o'clock. Fourth is correct, 5 is correct. So B is dynamic dispatch occurs when using trait objects like a dynamic trait, and B, that zero cost abstraction comes from monomorphism, that is concrete implementation generated at compile time, not at runtime. So yeah, both were correct. So now Rust for day 4 is core completed. Today you mastered enums with data, match destruction, result modeling, borrow versus move in enums, partial move semantics, and field level ownership tracking, and mutable borrow conflicts, trait definition, trait implementation, default method, trait bounds, static versus dynamic dispatch, monomorphization concept, and you are now in abstraction phase, not syntax phase. Now we switch to Python. Memory modeling. Concept 1. Python Day4 memory profiling. Nah, it's I guess Day 2 for Python. Let's go back to Python. If we needed to create, something, we can do it. Unless for Day 1. There is NumPy benchmark. We didn't use it at all. We were using it in Google Colab. So first of all, create another directory, main directory. Day, we call it 2. We'll get into Day 2. And for now, I'm just pausing this so that I can set up my environment. Hello, hello. We are back. Screen. Yeah. So we are back, and I have set up my collab right now. So this is day one. Sort of revise it. This is what we did. We created a data list and imported time. Sort of created time dot prep counter, and we counted the time it took for Python, and then we counted for time it took for NumPy, and we like tested it. Let's try running it all. We'll see. It's testing, and then what we did was create another array of 1 million, and then this, and then this is the code that we did. We sort of matrix multiplied and recorded the time it took for matrix multiplication in NumPy, and we tried doing it in this Python, and it took a lot of time, like mostly 120 seconds to 160, like 2 minutes or more than that. And after that, we sort of saw a dot flag or c dot flag. It was like, what are the flags in NumPy matrix? So we saw there is something called row wise or column wise something. If it's written in C, then it is row wise, and if it's written in Fortran, then it was column wise. So there was two flags, something named C and underscore and something, and there was another one called F and something. So let's pause it for now. This one, because it takes a lot of time. And what is this? Yeah. Yeah, C contiguous is true. That means it is row wise. Everything is stored row wise. So if we go row wise, we can access this very easily. We can multiply it very easily because it is cached. Whereas if it's F contiguous, then it means we can do column wise multiplications and arithmetic quite easily because it's then cached column wise. So that was day one for us. Now we come back to day two. This is our day two. So we have created a memory profile pi, and the concept one for today is that memory overhead. Memory overhead. We compare that Python list of 1 million integers and NumPy array of 1 million integers. We did it at day one. Now step one is the write this code. We'll write it. First of all, what we are doing is importing sys system, and then importing NumPy as np, and we are creating stuff. So let's do it. All right, so this is day two. So before doing this, I want to know the shortcuts. Uh, Control M must be Control M, then B. Yeah. How about text? Is there any shortcut for text? This is one, hashtag one. Come back here. So now we create import system. We import a system. Now we uh, import what? NumPy as np. Try writing it at your own pace now. Yes, these both are important. You will know. And as in Rust, we have also seen that we can use underscore, to just write values so that it's easy to read. Now we can see and say this is 1 million. We don't have to count zeros in that. And if we try to print, print n, but it will just ignore the underscore. Let's see. It does. Why? Acha, it's allocating runtime, so it's allocating me compute. Let it take some time. This only takes some time for the first time. Initialize, yeah. So see, we are just getting 1 million. We are not getting underscores. So it ignores it. Oh, sorry. I'm very, very sorry. That's what happens. Everything gets slow. So you were writing code. Now the n, which is size or length, which is 1 million. Now there is pi list, and that is equal to list of range n. Then there is np numpy array, which is equal to np dot range n comma d type is data type. So yeah, that's what we saw yesterday. np dot int 64. So we are saying create array like np dot arrange of size. Oh, there's spelling mistake. Arrange of size n, which is 1 million, and then data type is np int 64. So integer 64. This is the data type for this. And now we try to print print. How are we printing? We are printing Python list size. And we are printing system dot get. Yeah. We know that we'll be doing this. But I didn't know it was today. So this will give us the size of Python list in bytes, I guess. It will give us in bytes. Print. I hope so that everything is clear. Is this is clear? How about this? Just I hope this size is clear. History. Because I'm not recording it very high quality so that I don't spend much of a data while streaming or recording. We'll do sys dot get size of what? np array. Why numpy array is better than Python's list? Because arrays are stored contiguously, side by side in the memory. So when the CPU, let's say, fetches the first 8 byte, and the rest of the 64 bytes also gets cached, so it's easier on CPU also in NumPy. Whereas in Python, the pointers are stored contiguously, not the values. So for CPU, it has to figure out, where the pointers are pointing, and then get the value, and then do stuff with that, like calculate or add, multiply, whatever. Now what? We are getting this size of Python list index 0. So system dot get size of Python list, which is of size 0. Print, we are getting size of one numpy element, and sys. We are not doing sys anymore. What we are doing is np array, then item size. Is it? Let's not do this. This is of size, let's say, empty. We can edit now. I want to edit. Put editor settings. Let's say font size be 16. Or save it. Even though my magnification is less, I can still see my fonts. But it's clear. So now we have a program We try to run it. We get the Python list size is this much, whereas NumPy array size is this, and size of one Python integer is this, whereas size of one NumPy element is this. So what we are trying to achieve from you, run it, post the output. So this is our output. P, not P, P. Okay. Printing our output. And then let's attempt the MCQs before running. We ran already, but let's see. Now we know because it said which will use more memory. So I thought Python will use more memory, but here I can see NumPy is using a bit more. So question one, logical answer would be like option A. Python should use more memory, but that's not what's happening over here. We are seeing comparable results, but NumPy is taking a lot more. Like it's 112, it's 56. So there's a difference. Why? Python lists are heap object. NumPy uses contiguous memory, so and Python list stores pointers. All of the above. So I guess yes. 2D. I answered it. Let's see. It's hanging right now because we are using tabs and recording simultaneously. So yeah. So we are seeing both our outputs, both our options, both our questions were correct. Now the correct reasoning is here. Now we analyze our output carefully. This is where real understanding begins. Your output is this. Yeah, exactly. At first glance, this looks confusing. The list and NumPy array look almost the same size, which is 8 megabytes. But that is misleading. Why? I don't know why. The sys get size of PyList measures only the list container size, not the memory of integer object it points to. So the Python list stores the array of pointers that is 8 byte each on 64-bit machine, and each pointer points to a separate integer object. Now each integer object is 28 byte. So real memory in Python list, each element, the pointer in list is 8 byte, the pointer int object is 28 byte. The total element total per element is 36 bytes, and for a million elements it should be 36 MB. But why are we seeing only 8 megabytes is because we are only seeing the size of the cover. We are only seeing the size for the pointers that are stored there. We are not seeing the size, the accountability for Python objects, that is integer and going back to that integer object, each integer. So we are not seeing that size also. So therefore, this looks the same, but it is misleading. So, but the get size of PyList only reports the pointer size, that is 8 megabyte. It does not include the heavy name. It does not include the heap allocated integers. Whereas NumPy's array stores element contiguously, which is side by side alongside memory, like you're sitting with your friends side by side. Each integer is 64, which is 8 byte. Int 64, which is 8 bytes exactly. Int 32 is 4 bytes, so yeah, 64 double that, 8 bytes. No per element Python object. So there is no per element Python object. What does that mean? No per element Python. Yeah, there is no Python object in NumPy. It is just the numbers that are stored continuously. There is no pointer they have to follow, and there is no int object like Python. It is NumPy. Yeah. Its backend is written in C. So no pointer in direction. So total is 8 megabyte. This is not misleading. Now NumPy size is exactly 8 megabytes. Whereas the real size of Python would be 36 megabytes. Now the true comparison is Python list total memory, that is 36 megabyte, whereas NumPy array total memory, that is 8 megabyte. Now there is 4.5 times difference. That is wide. So this is why NumPy is efficient. Now MCQ, deep understanding. Why NumPy why is NumPy much more memory efficient? Because it avoids Python objects. That is correct. It stores an event contiguously. This is also correct. So I think all of the above will be the correct answer. Let's read third one too. It says it uses fixed width numeric type. Like int 64 right now. Yeah. Fixed. Is there also untype in NumPy? Because in Rust we saw there is untype, which expands or contracts as based on system's memory. If system is 32-bit, it will contract to 32-bit. If system is 64, it will expand till 64. So U type uses this thing quite efficiently, the memory of a given system. Now, question 4. Why is Python integer large, which is 28 bytes? Why is Python integer large, that is 28 bytes? Because it is a sort of Python object. So it stores arbitrary precision. It stores reference count and it stores type metadata. All of the above. D. I answered them. So let's go. Yeah, both are correct. So you now understand that Python integers are full object, which is metadata, ref count, arbitrary precision, and all the malloc and alloc, everything is included in Python object in itself. Whereas NumPy uses fixed width, which is C style integer. Contiguous memory plus no object overhead is equals to massive efficiency gain. So this distinction is foundational for ML system, machine learning systems. Now performance modeling vectorization. We compare Python loop with NumPy vectorized computation. Functions like this is x square 3x plus 1. So this is a function. What do we want to do is we compare Python loop, NumPy vectorized computation. So we are trying to compute for the value of x. All right. So let's copy this. That's what we are trying to do. And let's paste it away. Ah, aha, fx. Fx is equals to x to the power. How to say to the power? X. What if we just copy this whole thing? Because it gets copied in sort of MD. How about that? Yeah. See? This is how. So this is how we store. But we are still not getting this as superscript. All right, we can work with this. So now we are writing a new benchmark, which will try to solve this function. So let's go. Step 1 is write the benchmark. So we'll write the code. So we import numpy again as np, which is already there, but let's do it again. There is no need if you don't want to. But import time is important because we have not imported time in Google Colab right now. Now we have. And next is n is equals to 1 million, which is 0000000. Underscore, not the minus sign. Oh, damn it. And what? Then Python test. There comes comment. We are creating a Python list. What's next is py list is equals to list in range n, which is 1 million. We also have pi list from above. Where above? This. You have a pi list over here, and exactly the same one. Let's do it. If you only solely try to run this, you should be ready to uh, start start time dot time. Why don't we use prep time right now? We can use prep time because yesterday it said that it gives us, some better results, more. Uh, so let's ask it. Why aren't we using, prep time counter? Yeah, correct. Now come over here. Let's start time, and then we'll say pi result is equals to x squared. So x to the power x, no, x multiply x, not to the power x, or we can say x to the power 2, like this. Let's do this right now, and then plus 3 times x. All right, and say plus and then 1, and we'll say for x in pi list. Oh, so we are checking x for all the million possibilities that are there. I am hoping that what we are doing. So there is a list which contains, a number from 1 to 1 million, and we are looping for x from 1 starting to 1 to 1 million, and as soon as this x satisfy the expression, we are getting our x as a result. But it's not very encouraging to use this sort of loop. That's why there are formulas to solve these binary equations. Binary equations? Quadratic equations. What is this? Yeah, quadratic. What is to? Let's say polynomial. Yeah. Let's go with one. Binary and then quadratic. This is quadratic equations, no? Because it's square. So what means 4? So it's to the power 4. Let's go. We can revise maths anytime. Let's now. We are benchmarking stuff. Time dot time. Not Tim, not Tim. We are not talking about Tim Cook. It's time, not time. All right. Now we'll print whatever the result we might have got. P by th1, and we'll have to spend some time because this loop will take some time, not just some time, much of a time. There is end minus start. So now see, Python list is done. Now we are doing it for doing the same thing with NumPy array, and the NumPy array should be comparably faster than whatever this Python list will do. So that's what we are trying to do. Start timer is this, and then let's create an end timer. That is again time dot time. This is our time. Let's code in between that np result for np uh, array, and we are also learning how to deal with numpy array side by side. If we don't know already, I don't know already. So uh, 3 into numpy array. Let's see what is there. Plus 1. So this is the same equation, but instead of x, we are, instead of looping through Python list, we are just taking the numpy array and then multiplying with numpy array in place of x, and then replace the x with numpy array. That's all. That's all. Rest the equation is same, and we are just getting the numpy result directly. And now we shall do this. Copy, paste, vectorize time for numpy. UMPy vectorized time. That's it. Run it. So we'll run it. Ah, it was quicker than I expected, and it gave us the loop time. What about the result here? Print the result also. So py result. So I've printed. We'll try printing it over here so that it doesn't mess with our benchmark. Print by the result, and print what was a numpy array. I want to see the format in which, not array, the result. I want to see format they get us the result. Why is it still running here? Did we do something wrong? Automatic saving failed. This was updated remotely or in another tab. No, this should be saved. Ah, so there's some error. Why is it? Nobody knows. Did we not just solve it? So why is it showing us error? Ah, shit. We are hanged. We are hanged. Damn it. Ah, shit. It's hanging too much. Or like till it loads, or we should wait for it, and till then we shall see the questions. So which will be faster? Obviously the numpy vectorized. Correct? What are we getting? I think we are getting the whole million. Damn it. I should have done this. Shit. That's why it's hanging. Oh shit. What have we done? Why? Why? Let's control it. Erase everything. As for here, just remove these two lines and everything should fit in place. Yeah, everything does fit in place. Now we are not hanging. Everything's worked. Now MCQ before running. You should have told us first. Yes, we have some RAM. Which loop will be faster? So obviously NumPy. We all know. That's why we are using NumPy. And the second is why NumPy executes in optimized C. Yes. Python loop has interpreter overhead per iteration. Yeah, all of the above. Yeah, you all know this. All of the above. It's D. Now we are running, and I have my own question. Why are we not using time time dot pref? What is that? Time dot pref counter. COUNTER. Instead, time dot time. Ah, let's go. Let's try saving it again. Will it save? Should save because it doesn't have 1 million values to save right now. Let's see the diff execution output. What is this? Why is it? Yeah, save success. And our questions were correct, and it took 0.18 seconds for Python loop, 0.0056 seconds for NumPy. So it's 30 times speed up. Now that is interpreted overhead plus C level vectorization and contiguous memory. That is the speed up. Now your question is excellent. Why are we not using? It always says that, and then makes me feel down. Why are we not using time.pref counter instead of time.time? Now the answer to it is this is system level benchmarking question. Short answer is we should use time.pref counter for benchmarking, and it is more precise. But the difference is that time returns wall clock time, the seconds in epoch, at a lower resolution. Can be affected by system clock adjustment, not ideal for micro benchmarks. And time pref counter, which is high resolution timer, it is monotonic, cannot go backwards, designed for measuring short duration, and includes the time spent sleeping. Best choice for benchmarking. Now I am hearing a lot of noise. Ah, now this is much more relaxed, no more noise. Earlier there was running going on. Now question 3, MCQ type. Uh, which is monotonic, never goes backward. Time.pref counter, I guess. Yeah, monotonic, cannot go backward. This can go backward. Lower resolution can affect system clock adjustment, not ideal for micro benchmark. So third is, the industry level benchmarking is B, always. So this can never go back. And fourth is, which is preferred for benchmarking small interval? A, this is. Now improve your benchmark. Rewrite timing section using this and rerun post updated timings. So let us first of all copy the cell. Did we copy it? Copy it one step. All right. So we have to paste it also. Let's wait it, paste it. So we have pasted it. And can we replace this? Or can we replace? No, 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 no. We don't want to reload. Replace. Can we replace this? Run selection. Add comment, hide code. Nah, we can't replace it altogether. I want to edit, select all, find and replace. Yeah, find and replace. There is. So let's check for this and replace it. Edit, find and replace. Control H and Control G. All right. Find this and replace it with this time.pref counter. Not this here. Time.pref counter. Yeah, this. Replace all. Okay. Now let's see. This is 1 million. Now range, good. Time.pref counter, nice. Pref counter, nice. Pref counter, pref counter. Yeah, let's try running it. Some errors. What is it? We also did for this. No, that was it. No pref counter for this. What is happening right now? We broke something. We broke something. Will it run? It doesn't. Start time dot pref counter. What's wrong with this? Module time has no attribute. Pref नहीं perf का PRF damn control why 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 whatever this is. Let's copy it first. Yeah, I'm making a mess. Edit, find the place, find PREF counter and make it PERF, right? So how about now? Will it run? Let's see. Let's see. Yeah, it runs. And there is not much of an error. But all right. These two are the same code but gives different output. No worries. No worries. We'll just make it time manually. TIME. Then TIME. There's a Facebook thing. Yeah, we can also use this. I sometimes forget that I used Facebook. Yeah. Now this is time. It runs. Good. This also runs. Nice. Then rerun post updated timing. After that, we conclude day 4 and generate your structured log. Alright. Is that it? This is such a slow progress. and we completed it in like it's not even 12 o'clock. And I thought it will take sort of 4 hours or something like that. But it didn't take much of a time. Since this is ending over here, what I'll be doing is I'll be starting a live stream right now because I'm not going to sleep and I answered something incorrect. Let's see to it first. You answered A, which is incorrect. Correct is B. What I answered A, which is preferred for small intervals. Small interval. This. Oh, this is not very accurate. So this is very accurate. So B. Yeah, I am wrong. Sorry, I am wrong. So this is preferred for benchmarking small interval because it is very precise. I know, sort of scientific level precise. It provides high resolution, monotony guarantee, and designed for performance measurement. Time is for timestamp, not benchmarking. So benchmark analysis now results are that Python loop that is 0.226 seconds and NumPy vectorizes. So this is 45 times faster. Now slight difference from previous run is normal due to CPU scheduling, cache effect, and background processes. Why NumPy wins? System view is that Python loop interpreter dispatches per iteration, Python object arithmetic, reference count updates, and dynamic type checks. Now NumPy, which is tight C loop, fixed with integers, SIMD optimization possible, continuous memory, and no Python level loop. This is foundation of ML acceleration. Now the final concept check is this question: why does vectorization reduces interpreter overhead? It removes vectorization, it shift computation into compile, it reduces per element type checking. So there are multiple things. Python loop खत्म हो जाता है. It shift computation into compile code and it reduces per element type checking. So it's all of the above. I am guessing that. After that, Rust and Python objective Day4 are complete. All right. So I think since everything is complete, after this, I'll end this and upload it. This vectorization, eliminate Python loop overhead, executes inside optimized C, avoids per element dynamic dispatch, works over continuous memory. You now understand both memory model and performance model difference. A4 is complete. All right. So this is it for now. These are the codes. You can try writing them on your own. Just type it out. It's easy. Use Google Colab or what, and I'll end it. Bye bye. Where is it?